Hey everyone, welcome back to our Master Grade 6 KPSE Math series. I'm so excited you're here for part 2 of our exam prep journey. Today we're going to build on that knowledge and dive into even more essential topics that are sure to pop up on your KPSE exams. We'll be tackling divisibility rules, exploring least common multiples, deciphering patterns, and even conquering area, volume, and time calculations. Don't worry if some of these sound intimidating. We'll break them down step by step in a way that makes sense. Let's dive right in. Alright, let's start by demystifying divisibility rules. These are like shortcuts to tell if a number is divisible by another number without actually doing the full division. Let's take the number 350 as an example. First up, how do we know if a number is divisible by 2? It's simple. If the last digit is even, the entire number is divisible by 2. In the case of 350, the last digit is 0, which is even, so 350 is divisible by 2. Next, let's look at divisibility by 5. A number is divisible by 5 if the last digit is either a 0 or a 5. Finally, a number is divisible by 10 if it ends in a 0. You guessed it, 350 fits the bill. Now let's talk about the least common multiple, or LCM. The LCM is the smallest number that is a multiple of 2 or more given numbers. Let's say we want to find the LCM of 18, 24, and 36. One way to find the LCM is to list out the multiples of each number until we find the smallest one they all share. However, there's a more systematic method using prime factorization. So the LCM of 18, 24, and 36 is 72. Word problems can sometimes seem tricky, but let's break one down together. Imagine a problem that says, in an election 1,200 people were registered to vote. If 850 people actually voted, how many registered voters did not vote? We know the total number of registered voters and the number who voted. To find the number who did vote, we need to subtract the number of voters from the total number of registered voters. Therefore, 350 registered voters did not vote. Let's unravel another pattern-based problem. Consider this sequence, 2, 4, 8, 16, what's the next number? First, we need to figure out the rule governing the pattern. We can see that each number is double the previous number. To find the next number, we simply multiply the last number in the sequence, 16, by the common ratio, 2. 16 times 2 equals 32. Therefore, the next number in the sequence is 32. Let's shift gears and delve into the world of geometry with area calculations. Suppose we have a rectangle with an area of 50 square meters and a length of 10 meters. What is the width of the rectangle? Remember, the area of a rectangle is found by multiplying its length and width. Area equals length times width. Plugging in our values, we get width equals 50 square meters divided by 10 meters, which is 5 meters. Therefore, the width of the rectangle is 5 meters. Decimals might seem intimidating, but they're just like regular numbers with a few extra steps. Let's say we need to subtract 3.25 from 7.8. First, we line up the decimal points, adding a 0 to 7.8 to make it 7.80. Now, we subtract as usual, starting from the rightmost column 0 minus 5. Continuing with the rest of the digits, we get 7.80 minus 3.25 equals 4.55. Conversions are all about understanding the relationship between different units. Let's convert 6,500 meters into kilometers and meters. Remember that 1 kilometer is equal to 1,000 meters. To convert meters to kilometers, we divide by 1,000. So 6,500 meters divided by 1,000 equals 6.5 kilometers. Therefore, 6,500 meters is equal to 6 kilometers and 500 meters. Let's imagine we have a box with a length of 5 centimeters, a width of 4 centimeters, and a height of 3 centimeters. What is the volume of this box? The volume of a box or rectangular prism is found by multiplying its length, width, and height. Plugging in the values from our problem, we get volume equals 5 centimeters times 4 centimeters times 3 centimeters, which equals 60 cubic centimeters. Therefore, the volume of the box is 60 cubic centimeters. Adding fractions is a breeze once we have a common denominator. Let's add 1/4 and 3/8. First, we find the least common denominator of 4 and 8, which is 8. To get a denominator of 8 for 1/4, we multiply both the numerator and denominator by 2, resulting in 2/8. Now we can add the fractions. 2/8 plus 3/8 equals 5/8. Let's practice multiplication with a real-life scenario. If a bottle contains 250 milliliters of juice, how many liters of juice will 8 bottles hold? First, we multiply the volume of one bottle by the number of bottles. 250 milliliters per bottle times 8 bottles equals 2,000 milliliters. So, to convert milliliters to liters, we divide by 1,000. 2,000 milliliters divided by 1,000 milliliters per liter equals 2 liters. Let's talk about time conversions. If an athlete completes a race in 135 seconds, how many minutes and seconds is that? We know that there are 60 seconds in a minute. To convert seconds to minutes, we divide the total seconds by 60. So 135 seconds divided by 60 seconds per minute equals 2 with a remainder of 15. Therefore, the athlete completed the race in 2 minutes and 15 seconds. Equations might seem intimidating, but they're just about finding the value that makes the equation true. Let's solve the equation 2/3 x equals 4/5. To isolate x, we need to get rid of the fraction 2/3. We can do this by multiplying both sides of the equation by the reciprocal of 2/3, which is 3/2. This simplifies to x equals 12/10. Simplifying the fraction, we get x equals 6/5 or 1 and 1/5. Let's tackle another equation. 3x minus 6 equals 9. Our goal is to isolate x. First, we need to get rid of the constant term, minus 6. We do this by adding 6 to both sides of the equation. 3x minus 6 plus 6 equals 9 plus 6. This simplifies to 3x equals 15. This gives us x equals 5. Let's dive into a word problem involving money. How many SHA 50 notes are there in SHA 1000? To find the answer, we simply divide the total amount of money SHA 1000 by the value of each note, SHA 50. 1000 divided by SHA 50 per note equals 20 notes. Let's say it's currently 8:45 a.m. What time will it be in 5 hours and 30 minutes? To find out, we add the hours and minutes separately. Adding the hours, 8 plus 5 equals 13 hours. Since there are 12 hours in a standard clock, 13 hours is equivalent to 1 p.m. Adding the minutes, 45 minutes plus 30 minutes equals 75 minutes. Adding the hours and minutes together, we get 1 p.m. plus 1 hour 15 minutes equals 2:15 p.m. That's it for part 2 of our Master Grade 6 KPSE Math series. I'm so proud of you for sticking with it and tackling these challenging concepts head-on. Remember, the more you practice, the more confident you'll become. Practice is the key to unlocking your full mathematical potential. Stay tuned for part 3, where we'll explore even more essential KPSE math topics. Don't forget to like, share, and subscribe for more educational content. Keep those brains buzzing, and I'll see you in the next video.